As you can see, IP Center follows an I/V3 layout. Under Service Transition, we have IPCMDB for the Configuration Management Database, and IP Project for Project Management. Under Service Operation, we have IPCM for Change Management, IP Escalate for Client-Facing Escalation Automation, IPIM for Incident Management, IPPM for Problem Management, IP Radar, our custom workflow engine, IP Reports for capacity and trend reporting, IP Mon for monitoring your entire infrastructure. Under Continual Service Improvement, we have IP Six Sigma, which provides visibility into our Six Sigma practice, and IP ITPA, which provides reporting around process automation, such as these graphs. Under Service Delivery Management, we have IPSLR for providing point-in-time service level reporting. These graphs are an example. ITIL doesn't have a placeholder for technology, so we have a Service Technology tab. Under Service Technology, we have IP Automata for runbook automation, IP Classify, our Bayesian learning engine, IP Manager for virtual NOC management, Instead of having knowledge management be a wiki or a few SharePoint sites that the engineer needs to search, we actually want our systems to pull the appropriate knowledge-based components and present it directly to the engineers, as opposed to having him search the knowledge management system. Here, we have done just that. IP Escalate pulls together all the different knowledge fragments that an engineer needs to perform his diligence. Here, we have a direct link to the runbook that was collected during knowledge transfer, the escalation information, details for the environment to tell you about the incident, the host, the support set, what are the support hours, etc., etc. The next point that an engineer will face is, great, now I know, I have a problem on this host, here's my runbook. Was anyone else previously working on this? Again, to optimize the engineer's experience, what are the case notes, or what are the notes that the last engineer left here? In this particular case, standard blocking lock with the standard escalation process is what the engineer needs to follow should this come back. Now, that's all great if you are an engineer. At IPsoft, we do it a little differently. Instead of having an engineer utilize all this information, we have one of our virtual engineers walk through this process, pick up the ticket, go and query the CMDB as we already noted, extracts details regarding the application owners and the escalation contact for this environment. It goes through the process of connecting to the database, opens a SQL Plus session, extracts all the blocking lock information from the environment, and follows with custom escalation process based upon the CMDB information. In this case, the virtual engineer generates an incident management ticket with all of the extracted details and recommended course of action, and sends it to the escalation contacts identified in the CMDB. If there are no pre-approved actions, the virtual engineer will escalate to the client and ask regarding a specific remediation path. Should we kill the session? Should we trace it? Should we downtime monitoring? The approver can either click the link provided in the ticket update or interact with the interactive voice response system, in which case the automation will run the case to completion. If automation would resolve 100% of the problems, we wouldn't need engineers. We have designed the automation to handle deviations the same way as an engineer would. When it does not know how to proceed, it simply stops and escalates to a senior engineer. During a traditional escalation, the first question a senior engineer would ask is, hey, I know this process always resolves this problem. What's happening now? Instead of having to recite everything that was performed before, having the senior engineer go back and verify it, we provide direct access to all the standard out, standard in, and standard error for every step and every decision point, providing a complete audit trail. A key note here is that the automation was able to perform diagnosis, escalation, and remediation in a fraction of the time it would have taken an engineer to pick up these activities. For this incident, automation started at 1714. You can see that by 1717, the automation had run through, query the CMDB, find out who owned the environment, gone in and logged into the database, extract all the appropriate database information, cut a ticket, and was in the process of performing escalation. Here we see the incident management ticket that was actually generated by the automata. The automata provided an update with all of the event management data, along with a nicely formatted version of the data that was extracted by the virtual engineer. At the bottom, you have the list of known remediation methods. Again, if there are any pre-approved actions, the automation would simply perform them. In that case, we generate a list and a one-time URL hash. An approver simply clicks this link, selects which task it should perform, and the automation will follow the chosen remediation path. Next example, I have pulled up a sample interactive voice response, or IVR, that was custom developed for one of our clients. What the IVR does is that it allows them to directly interact with the IVR while the IVR would perform the actions on behalf of that engineer, connecting to the client's back-end systems, querying the databases, interacting with firewalls, their spam folders, etc. in real time, providing standard request fulfillment of a level 1 or level 2 engineer. Let's watch this automata execute. I have triggered it, and now it's calling us.
Hello, you have reached an automated support line powered by IPsoft. Press 1 for system help information. Press 2 for nightly job information. Press 3 to toggle maintenance mode. Press 4 to query a lead. Press 5 to restart one of the engines. Press 9 to repeat this menu. 1 second. We are collecting real-time status information. Please be patient.
As you can see on the screen, you can see the information the IVR is relaying. Here I have asked the system to go in and give me the health check for the environment. It's going to log into some spam filters, it's going to log into a database server, it's going to check replication status to a slave, etc., and report back to me in real time. We can follow exactly what it's doing here. You can see the exact Unix commands, and if you expand these, the actual details it is getting back from the environment.
Active engines on production SMTP01. Email engine. Active engines on production SMTP02. Lead engine. Email engine. We have 10 MySQL threads on main production database. Queue sizes on production spam filters. 01, 0 inbound, 1 outbound. 02, 0 inbound, 1 outbound. Replication status is up. Replication is 0 seconds behind.
Seeing this run, you can just imagine the benefits to your environment. We are able to automate many things that people thought were previously impossible. In this simple example, you could see what we can provide from a request fulfillment. You can also extend it to deployments, releases, etc. All the way to the left, you'll see these scores, which are unique to IPsoft. We incentivize our engineering staff just as you might incentivize a classic sales organization. A mathematical formula incorporates all these metrics to come up with a score for each engineer. These aren't simply passive scores. Rather, scores account for monthly performance bonuses. Every engineer can see in real time their own scores and the scores of other engineers. In this way, we encourage competition and allow engineers to know where they stand compared to their peers. In calculating these scores, this QoS feedback from our clients is a multiplier on that score. If clients aren't happy and give a 0 score, the engineer's associated bonus is wiped out by the 0 multiplier. Similarly, drops and outages and infractions all count negatively against the engineer. Because of this, our engineers are driven to be customer satisfaction focused, to provide the root cause analysis that it is typically lacking, to provide the feedback that a good organization looks for. Over time, we modify the equation used to come up with the overall score, which allows us to fine-tune the behaviors we're looking for. This leads us to IP Manager, which is our virtual NOC manager. At IPsoft, we no longer rely upon eyes on screen, so to speak. We've developed a virtual NOC manager, which takes incidents, problems, client requests, and load balances them across the operations team, preventing hotspots or underutilization. IP Manager routes tickets based upon the individual's availability. Again, our engineers are working through IP Center, so IP Center knows if they are on a call, in a client meeting, or working on another incident ticket. The skill set for the engineer. We have a matrix for every engineer that maps the different technical skill set ratings. The skill set for that specific client environment. We map which engineers are most knowledgeable about which client environments. And the QoS feedback for that client. The engine optimizing the Six Sigma scores we showed you on the previous screen optimizes the client experience and QoS. Via the QoS feedback, clients can actually determine which engineers they want to work with. If a client has had successful deployment with a particular engineer and has given positive feedback, for that next deployment, and if that engineer is available, IP Center will attempt to route to that engineer via an interrupt. The opposite is also true. Routing will send an interrupt to the engineer, asking if they can address the specific issue. The engineer can either accept or reject the request. Standard communications protocols include our internal instant messaging systems, the IVR to our desk phones, and their cell phones. Finally, we come to IP Classify. This provides our Bayesian learning engine plus rule-based classification. For all events that come in through IPMon, we have associated metadata, so we can tell if something is a database issue, a network issue, a priority 1, a priority 4, etc.